This section is concerned with scientific notation, and parts of it may be a review for you. You may have seen it somewhere in your past. Certainly if you've taken some science classes, maybe you've actually used them in calculations. I don't think it would be a bad idea to go ahead and watch this quick review and get my take on it. Anyway, scientific notation is used to deal with very large or very small numbers. Numbers with a lot of decimal places, either way. So here, when you look at this number, and it's hundreds, thousands, millions, billions, trillion, it's 9,600,000,000,000, which I think is somewhere around our national debt right now, which is an unimaginably large amount of cash. But I think it's somewhere in that neighborhood of this number. Anyway, there are 9,600,000,000,000,000. There are only two significant digits in this. Significant digits are 96. So scientific notation extracts the what you want to take out of it as far as significant digits, and then shortens the length of it, and also takes advantage of exponents. And since you just learned about exponents, then we can take advantage of these exponent rules for calculating with scientific notation numbers. All right, so how does this work in this case? This is going to be 9.6 times 10 to the 12th. So let me explain that. The scientific notation, we always have one digit and then a decimal point. And there may be more digits after the decimal point, depending on how many there are that are significant, or how far we want to round off. You know, if this number had nothing but non-zero stuff in it, then we would probably round it off somewhere. But always one digit. And so my cutoff is here at the 9, and so it makes it 9.6. And the 12 comes from the number of places after this cutoff. So there are 3, 6, 9, 12 places. That's 9.6 times 10 to the 12th power. All right. Now, it's not just notation. It works mathematically, because 10 to the 12th would be like multiplying 12 tens together. And if you did that, you would get 1 followed by 12 zeros, or 1 trillion. So if you were to multiply 1 trillion by 9.6, you'll get 9.6 trillion, or 9,600,000,000,000. Okay, but that's the idea there. And this is one of the few places in algebra we ever use the multiplication cross symbol. And we usually avoid that because we're working with x's in algebra, but it shows up. It's traditional in scientific notation. All right, I'm going to erase the board and we'll look at a very tiny number. So here's a rather tiny, small number, 0 point, and I have 7 zeros here. 1, 2, 3, 4, 5, 6, 7 zeros after the decimal point, and then 1, 2, 0, 3. Well, the significant digits in this number would be the 1203 right here, and the string of zeros before them are not considered significant as far as significant digits. So how do we do this? Our cutoff, again, is going to be after the first significant digit, 1, and I'm going to write this as 1.203. So here I kept my 4 significant places, but again, 1 decimal here, and then a decimal point. 1.203 times 10 to the what power? Well, let's count. From this decimal point to that decimal point is 1, 2, 3, 4, 5, 6, 7, 8. 8 places. And so this is going to be minus 8. Now, when people learn scientific notation, often they're taught, well, if you move it from right to left, you have a positive exponent. If you go from left to right, you have a negative exponent, depending on what you're doing. I may have that reversed. I wouldn't memorize these techniques in terms of left to right. Just think big or small. A very small number is going to have a negative exponent. A very large number, like the last number, the 9.6 trillion, is going to have a positive exponent. So think in terms of big and small, and you won't get left and right mixed up. Very simple. Well, now what is this? 10 to the minus 8 is 1 over 10 to the 8th. Remember, I changed my sign of my exponent. It becomes a fraction in this case. And this is 1 over 1 followed by 8 zeros. 2, 3, 4, 5, 6, 7, 8, which is 1 over 100 million. All right, so this number is really 1.203 divided by 100 million. Okay, that's what that would mean. But as you can see, if you took 1.203 and divided by this very large number, you'll get a very small decimal number there. All right, well, we're going to erase the board, and let's look at going the other direction, taking a scientific notation number and writing it out in the ordinary form. Okay, well, here's a small number, 1.49 times 10 to the minus 6th power. And you might wonder, where do people deal with such tiny numbers? Well, scientists, when they look at things at the atomic level, very, very small, these numbers can be very, very, very tiny. In other words, in decimal form, if you wrote it out, it might be 30 or 35 places. And so at the extreme end, you would see numbers that small in physics. Anyway, scientific notation is really mainly for scientists and engineers, but it's a traditional algebra topic. And it's so nice because we get to build on our knowledge of exponents here and use them. All right, well, 1.49 times 10 to the minus 6th would be, all right, well, how does this work? Well, my significant places are 149, so let me make some room here, 149. And from this original decimal place, I'm going to make it smaller. It's negative exponent, so I'm going to make it smaller by counting back 6 places. So 1, 2, 3, 4, 5, 6. Let's see if I got that right. So it's 1, 2, 3, 4, 5, 6. 6 places backwards. Okay, there we go. And let me write this out. 0.1, 2, 3, 4, 5, 149. So actually I have 5 zeros and then the 1. That's your 6 places. And there it is in the more ordinary numerical form like that. The 1.49, 10 to the minus 6 incidentally is 1 over 10 to the 6th, which is 1 over 1 million. And so really this number is the same as 1.49 over 1 million. So if you were to divide by 1 million, 6 places, you would make it 6 places smaller. Anyway, but all you really have to do is go from here to here. And again, negative exponent means very small number. To take a very large number like 7.08 times 10 to the 12th power, that would be, well, let me use a different power. I think I used 12 before. Let's make it 10. 10 to the 10th. Okay. This would be 7, and then there's 10 places afterwards. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, now the 0.08 went here. So it's not like I added 10 zeros to this number. I have 10 places after the decimal point. So beginning here, there are 10 places. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Those 10 places were these 2 digits plus 8 more zeros. And this would be hundreds, thousands, millions, billions. That would be 70,800,000,000. All right, so there you have it. Next we're going to move on and look at calculating with scientific notation.